use it, do whatever. We don't call these permanent connections, but we do call them mechanical connections, okay? So the thing about mechanical connections is that some of these sometimes are buried. Sometimes, you know, they're out in the cold and they go through summers, they go through winters, they go through all the heat and the change right in the cold and everything else like that. So sometimes there's a good chance that these can loosen off, right? So that's why it's not rated a permanent connection. And ESA these days are always looking for a permanent connection. But sometimes you cannot put a permanent connection on the application. Sometimes it has to be mechanical. It's just the way it is. It depends what you're connecting to, right? So we'll always need mechanical connections. And then sometimes you want to be able to take the connection off and you want to be able to change it, or you're doing a temporary connection because you're setting up the site, right? Bringing power to your site. Then once you're done site, once you're done working, you want to disconnect everything, right? And you want to go home. So there is a place for mechanical connectors, but just know that this is not rated as a permanent connection. And so where would mechanical connectors be used? Safety fences, or safety wire on fences. So I'm going to get into the whole grounding and bonding thing later on why you would connect an electrical wire to a fence, and I'll explain that. But that is one of the occurrences that happens today, that there's a lot of fence grounding going on, and so they would use a mechanical connector. And that would be something like this, just a little split bolt like this, where you actually, so it would be one without a post, and essentially you just put two wires in, you tighten it down, and that's what's happening, right? Another example would be the U-bolt, which is the one that I just had. And so that's a fence post. So again, we're talking about the fence as well. And so this would go around the fence post. And again, we'll talk about grounding and why you're going to ground the fence. But because it's hard to compress a connector onto a fence post, we have to use a mechanical connector. And so we would use that. And so sometimes this would connect to the fence, and it would be tightened up against the fence. Then we'd have a piece of braid. And then so imagine you had a gate on that fence. So when the gate opens, you've got this flexible piece of cable that's actually attached to the gate that won't wear down over time, right? And so that's another example of why you would use a mechanical connector for an electrical application. Grounding to rebar, the exact same thing, and we'll get into more specifics on why you would ground rebar. Sometimes we make crosses. There's a mechanical application. One of the things that we're seeing a lot lately, and especially in Ontario, is data centers. Data centers are built in specifically in Ontario because we have the seasons, we have the winters, right? So what happens is a data center creates a lot of heat. So it takes a lot of energy to cool down a data center. So imagine all these pieces of equipment running in one room. You need all that HVAC. So if you know of a data center, there's one on Weston Road, there's a few on Weston Road, off the 400, you see these big data center buildings, it's just going to be a whole bunch of HVAC on top. And all it is air conditioning, just going on and on, cooling this equipment, cooling all those power units and CPUs and all those processors in order to provide data to us. And so what happens is, because of that sensitive equipment, we need to ground that equipment. And so that equipment normally sits on a pedestal, it sits on a raised floor. So you would have your cement floor, you would have a raised floor that looks like this, and then all your data equipment will be on here. And this would all be a grounded and bonded system. And so here's an example of where you would use a mechanical connector on a raised floor for a data center. You would use mechanical for that because there's the only other way. You cannot compress to that, right? Like there's no way I'm gonna be able to find a lug or like a thrift like this that's gonna be able to go around a 1-inch pedestal, right? I'm not going to be able to squeeze around that. And so the only other way is to weld it. And so a welded connection looks like this. But that welded connection creates heat, it creates smoke, it's a bit dangerous, it's old technology, and it takes a lot of time to do it. And we're going to do one of these examples later on today, and we're going to talk more about this exothermic welded connection. So the thing with the mechanical is that they're able to go in there, they're able to go in with their ratchet gun and able just to put it on really quick. And there's a good, so I just wrote an order this week for 2,200 connectors. So somebody has to go in and connect 2,200 of these connectors to these raised floors, because this raised floor is just huge. It's for a Microsoft data center. And so what they'll do is they'll go in with a ratchet gun and they'll put all the cable all crossed, interacted under the floor, and then someone will come in with those connectors, pick it all up, and then so there's a bit of speed there. And then also with these data centers and a lot of things, with data centers specifically, they're always growing, right? They make data centers so that they can add more, so they can add more and they can add more. And so there's a good chance they may need to disassemble, add some pieces, and then put it back together again. And so that's why you would use a mechanical connector for that. But good question. So because I'm just giving you mechanical examples, I'm going to get into the grounding. This is, so as it applies to, when we talk about that, this grid grounding, something like this that's across, that would be, imagine a big substation, right? So all your power goes to this substation that comes into Burlington, and then that substation will send power out to all the homes and stuff like that, so they downsize the power. So that grounding system there would be to protect, to dissipate any fault from lightning or some circuitry that's gone wrong, animals go into it, whatever, all of a sudden there's a short circuit, so all the energy will collect through the grounding system and then go into the ground, right? But when we talk about data centers, the reason they have so much grounding on data centers is because of static grounding, right? So you know how you guys walk all on the floor and the carpet and then you go touch a doorknob and then there's that spark? Well, that's called static grounding. You bring static grounding into a data center or to anything that's got very sensitive equipment, you're going to damage that equipment. And so that's why they take all the time to put all this equipment on these static-proof floors. They ground everything to make sure if there's any static whatsoever, they make sure it goes into the ground system and away from the equipment. Yeah. So, and I am going to talk more about it. This is kind of where I'm new at this. Like I'm talking about grounding, but I haven't even talked about grounding yet. But I'm just kind of giving some examples of the types of connectors.